My name is Mike Nicholaides. Just a little housekeeping. If you're having trouble hearing me, wave or just yell, I can't hear you. I would actually appreciate that. That would not be rude. Yeah, we're going to talk today about securing your Rails app. But first, just want to give you a little bit of background about myself. I and two other guys have a consultancy in Philadelphia. We're called PromptWorks. We do a lot of work in Ruby, Rails, JavaScript, infrastructure automation, Chef. We do a lot of testing, pair programming. We work really hard to make great software, and I think that we actually do. We have some amazing people on the team, and we work with some really awesome clients. So I'm really honored to be part of this team. If you're in Philadelphia, please come say hi, hang out at our office. We also, as Jason said earlier today, we have a great community. So if you're in town and want to participate in our Philly RB meetup, you'd be welcome. So please join us for that. So security has been a little bit difficult for us this year. Who remembers January and February? Who got so little sleep that they don't remember January and February? So Rails early in this year, we had some pretty severe vulnerabilities in the framework. That sort of brought security to the limelight for our community, but not just for our community. With the NSA, with Snowden, we in the United States are a little bit more cognizant of security. Is becoming more and more important to us. Additionally, users are becoming more aware and demanding more of us to protect their personal information, private information. On Hacker News for a while, Facebook's privacy was like the only thing you'd ever see. And maybe you have the HIPAA requirements for your application, or maybe you just have sensitive information. Security is becoming more and more important for us as we put more and more information online. So I'm going to talk about securing a Rails app. We're going to kind of go in three sections. First, I'm going to give you a high-level view of security. Then we're going to talk about with our Rails apps how to do that, and then I'm going to give you some recommendations. The first thing I want to say is that security is hard. It is really hard. It permeates every piece of technology in our web apps. Every part of our stack is affected. Our network, our hardware, the OS, our Rails app itself, databases, other services that we interact with, we have to be conscious of the security implications of that. And to make matters worse, there are people out there, as we speak, attempting to gain access to our systems. They look like this. They wear ski masks and a tie at the same time. And if your app is on the internet, they are actively trying to get into it right now. And maybe your threat isn't from random strangers who think of you as just an IP address. You have competitors, you have users who would like to game your app, and you have employees and developers who, depending on the type of data that you have, the type of work that you do, you might have issues there. So when your boss or your client asks you this, are we secure, is my app secure? What do you say? How do you respond to that? Security is hard. No. Yes, you say no. And then go home for the day. Security is really hard. Perfect security might literally be impossible. And so it sort of becomes, how hard do we try to make our apps secure? How much effort do we need to put in? How much due diligence do we need to do? I'm going to talk about, so this is what I think we need to know in order to evaluate how secure we are, how much effort we need to devote to being secure. I'm kind of grouping this under what I'm calling awareness. We need to be aware of our surroundings. This gentleman is not aware of his surroundings. That's sort of a broad way to put it, but in three different sections I'd call it. First, we need to know what our risks are. So how bad would it be? This is not a rhetorical question. This is a real question. How bad would it be if everything in your database suddenly found itself in the hands of your competitor? How bad would it be if somebody with malicious intent had access to one of your web servers or to your network? Maybe your web server is touching the internet, but your internal network is talking to that web server. How bad would that be? Really bad. Yeah. So, but it needs to. That's the sort of thing that you need to evaluate for yourself. And every app is different. How bad would it be if an attacker could impersonate one of your users or one of your administrators? Secondly, we need to know our environment, the environment that our app lives in. So what's outside of our app that we cannot control? So those are things like our server. Who else has access to the server your website is hosted on? Your network. Who else has access to your network? Is it on the internet or is it an internal network? That sort of thing. Who has access to your hardware? And where is your data stored? So you need to know your environment. Additionally, so once you know your environment, you have to know your perimeter. So what of your app is touching the environment? This is your surface area for attacks. So if you need to know what your ops architecture is and be aware of how it's affected by the environment. So what servers are talking to what? Where are they located? And how are they communicating? Right? Is your communication encrypted or not? What networks is that communication going over? What libraries and services you use? Can't always, you can't always predict what malicious code might be in some open source libraries that you have. So that's an important concern to some applications, not so much to others. So if we can evaluate, using those things, we can evaluate what our risks are and what we need to do to make ourselves secure. That will give us a good sense of how much effort we have to put into making ourselves secure. So these are some things that I can't answer for you. You have to answer for yourself. But given that, if you take that, what you find out from asking yourselves these tough, probing questions, we need to develop from that a security strategy. What's our strategy going to be? In other words, how do we go about protecting ourselves from tech-savvy people who dress in all black, wear hoods and handkerchiefs, and code with hammers? But in seriousness, we need to have a strategy. Our strategy needs to be to minimize the risk, right? So the risk that our environment bring us, the risk of, for example, don't store data that you don't need to be storing. That would be risky if somebody else got it. So we want to be minimizing the risks, minimizing what we touch in our environment in order to keep ourselves as safe as possible. We need to minimize our perimeter, so only expose the ports that you need to the internet. Only expose the machines that need to be exposed to the open internet to the internet. Using SSL is probably a security strategy that we should all be using. Minimizing what information about our operating system, our server software, Nginx, whatever, is being exposed to the outside. Another part of our strategy is we need visibility into our apps. And you need to figure out how much visibility you need. So visibility comes in two main pieces. So the first piece would be we need audit logs. Audit logs, we would be logging things like key transitions. So an example of a key transaction would be if your app transfers money between users, that every time you transfer money, that's a key transaction. If your app does something valuable that an attacker would find to be valuable, that would be a key transaction. So we would need to be logging those things. We need to be logging blocked access attempts. So when somebody tries to log in with the wrong password, we need to be logging that. If they try to do something that they don't have permission for, we shouldn't just blow up with an exception, although that's a good thing to do, but we should be logging that. These logs are extremely useful for forensics. So something actually does happen and you have an intrusion, you need to find out what happened. So that's why you have these logs. Or if you realize something funny is going on, you need to have logs that are easy to understand so that you can kind of decipher what's actually going on. Additionally, these logs need to be append only. So I was talking to a guy last week. He worked for a company, and one of the developers went rogue and started stealing money through the computer system that he was working on. And he covered his tracks for a long time because he was deleting the logs of the transactions that were happening. So he transferred money to himself and deleted the logs. And they had no way of knowing that they had no way of like figuring out that that's what was going on because the logs were just gone. They were relying on them. So you need append-only logs. So maybe this is a service that you can send your logs to, that if somebody gets access to your system, they're not going to have access to modify the logs. And you might be saying, okay, Rails logs everything. Every request is logged. And we can probably figure out what was going on based on that log. But it's 3 a.m., you get a call that something has happened, we had to shut everything down. We need to find out what happened right now. Why not spend a few hours right now logging the things that you know are important, so you don't have to be reading through these Rails or request logs. Okay, so that's what I would recommend for some strategy. The other part of visibility is alerting. So we want to be alerting on things like business anomalies. So, for example, if you transfer money, if somebody transfers $1 million, you should get an alert about that because either something really wonderful has happened or something really horrible has happened. Or if you usually transfer $1 million at a time, that's like what your business is, and you find yourself transmitting pennies, something weird is going on, and you should get an alert about that. It's much easier to fix something before it actually happens. The sooner you can find out what's going on and fix it, the better before the damage is done. We also need to be logging, if this is important to your app, usage anomalies. So that's something like a user is making 100 requests per second. So maybe he's scraping his personal feed, and that's not a problem. But we should still get an alert about that because maybe he's actually iterating over some strings and trying to find a vulnerability. If we can find out that that's going on before he actually gets in, that'd be good for us to do. Next, part of our strategy needs to include a plan. We need to have a plan of how to handle intrusions. So just for instance, to be very explicit, you find out that someone gained access to your system and they've taken some data or some money or done something malicious. What do you do? So if you don't have a plan, this is a good default plan. Stop everything and take it offline. You're stopping the bleeding. Figure out what happened and what they did, and then fix that. And then you have to figure out how they got in, and then fix that. And then once all that's fixed, you apologize to your users, and you bring everything back online. If you miss a step there, for instance, if you miss the patching and security hole step, you bring everything back online, they're just going to do it again. Or their buddy is going to do it again. So that's a good plan. If you're PayPal or a hospital or bank, you probably have other needs and other plans, but if you don't have a plan, use that one. Another tip, if you need to change something about your architecture because there was a security vulnerability and then you need to start everything back up, if you're not on like Heroku or have everything in Chef, you're going to have a hard time. So do this now while it's easy so that you're not doing this under pressure to get money coming back in from all your users because they're not using your service. And the final part of the strategy is to include this, in my opinion. So we need to make security part of the process. If security is important for you, you need to figure out a way that it actually happens and happens in a way that's not just an afterthought. So maybe that's every sprint has security review, or maybe it means that every code review, which maybe that's happening every sprint or while you're doing pair programming or whatever, has to include a security component, like you have to be looking for security. Maybe it means that every release you do a security review. Security is hard and it permeates everything in our apps. So if it's not part of the process and we're not constantly evaluating it, we're very likely to miss something. This strategy, making security part of the process, I think will make us security in the front, this is the side, business in the back, which I think is a good posture to have, not as a human, but as an application. So, I just looked like that he looks like he just finished evaluating an insurance claim. Okay. Yeah, so we came here to talk about Rails apps. I'd love to go over everything that you need to do in your app to have a secure app, but they've only given me an hour and a half. Right, an hour and a half. 2 hours. So I don't have that much time, but even if I did, it would be infeasible. There really is so much that you have to do and so much to learn that really I want to focus on some fundamentals and hope that those fundamentals will sort of guide the learning that you do as you go on. So the fundamental security problem for web applications is that users can submit arbitrary input. So does anybody recognize this format, what this is? Yeah, so this is JSON. This is JSON part of an HTTP request. So this is pretty much what goes over the wire when someone is submitting an HTTP request, whether it's through the browser or through curl or through telnet. So it is crazy easy to submit whatever you want to any server as HTTP. So this is something we're pretty familiar with, but sometimes tend to forget. And that's not, the fact that we can submit arbitrary input is not, it's a problem, but it's not a bug, it's a feature. That's what makes the internet work, and we have to learn to accept that. So what that means is we cannot trust user input. Whether it's coming from parameters, cookies, request headers, the URL in the path, incoming emails, maybe another service is parsing emails or you're parsing your own emails, uploaded files, input from other services, or maybe you got information somewhere else. All external information that we get is suspect. And especially most of these things are coming in through the HTTP request. So everything is suspect. When you get data that comes from external sources, especially HTTP requests, you have to assume that it's coming from somebody, it may be coming from somebody like this. Somebody who wears a black hoodie and a Halloween mask, which helps him code better. Yeah, okay, so what do we do? All input is suspect, so let's just not take input, right? That sounds like a good strategy. If you can do that, that's awesome. I would go on your job. So let's talk about how, there's sort of 5 categories of how to deal with this input that's not trusted. 6 if you count not doing anything. So the first one is called blacklisting. It's a fairly simple concept. It's a list, a blacklist of input that is not acceptable. So here's a good example of using a blacklist. So this is like the app that lets you choose your own subdomain. Like, instead of going to www.freshbooks.com, you have to go to johnstengosfanclub.com or .com.freshbooks.com because you had to choose your own subdomain. Right, so this blacklist is telling us that you can't choose www because that's taken, and you can't choose mail because we use that for internal stuff. And if somebody were to choose those, it would be maybe confusing to the user who got it. Maybe it would be dangerous because depending on how your setup is, that might have given them access to change code that shows up on your front page. Yeah, so that's a good use of blacklists. But even when we use it the right way, it's not foolproof. So, what if they gave you capital W's? Are we checking for that? That's even though we have a blacklist, we still have to check for that. What if they put a space before it? What if they give you an empty string? God forbid that actually gives, their account is now what people see when they go to freshbooks.com or whatever. Or what if they put in 4 wwws? So that might look like it's your normal www page, but then they can perhaps modify the content and show whatever they want and fool people. So these aren't necessarily bad, but we have to consider all the options because some of them could potentially be bad. And that's the problem with blacklists, is that they err on the side of letting bad input through. That was actually a good example of using a blacklist. This is a bad example. Here's a naive approach here. this is what we're trying to do. We want to build up a SQL string. In this case, we're just like doing a single variable, but there are apps where you actually do need to build up a SQL string that's more complicated than this. And you have good reasons for that, right? So a naive approach is we'll make this blacklist, that's the first line, so regex of bad input, and then we take the parameter name that they sent in and we gsub it out. So like remove anything that's in that regex out from the string. That's a naive approach, and it fails for a number of reasons, some of which you might not even have thought of. Right, so I don't know if you noticed an example, but that was case sensitive. So what if they put in lowercase select? If we're removing the word select from it, what happens when somebody gives us input like that? It ends up with select again. So okay, now it's getting tricky. It's like, okay, let's forget about this gsub business. For now, we'll split on white space and then remove add tokens that way. Okay, what if they give you that? Right, you might not have expected that. Because that is actually valid SQL for some servers at least. Okay, so you say, I'm going to make it tokenized and we'll break the string into valid SQL tokens. Okay, that's not really the problem. The problem is that we have that blacklist error on letting too much through. And there are some things that we may have forgotten, something like truncate, that'd be bad. But also maybe there's undocumented cases that we had no way of knowing. So that's a big problem with blacklists. So they're easy, but they have a lot of problems and can't be used in that many situations. Occasionally effective, but you have to know all the bad inputs. Okay, opposite of blacklisting, waitlisting. This is a great example of waitlisting that we're all probably pretty familiar with. This user has a number of columns, and the columns that we allow you to assign, if you pass in a hash or name and address, right? We don't want somebody to pass in admin and then change their own admin flag. So this is great. The only problem, which isn't that much of a problem, is that if we add a column birthday, we have to make sure we add it to the birthday list. So whitelist error on the side of not allowing good input. So the error on the side being too strict, which for security purposes is generally good. So whitelists are the most effective. If you can do it, it is the most effective. The Rails HTML and CSS sanitizers, by default use a whitelist to whitelist HTML tags and CSS styles. When a new HTML5 tag comes out, they have to add it to the list, but that's a small price to pay. Like Ruby is something that you cannot whitelist and still, take Ruby as input. That would be pretty effective. Okay, so another method that we use to deal with untrusted input is called sanitization. This is that we need to treat user input as code. So, for example, we want a user to be able to give us some HTML for their bio page, right? And we want them to be able to give us HTML. We're going to treat that HTML as code. We're going to just put it in our site. The problem with that is that obviously the script tag, if we're not careful, is they can do whatever they want and impersonate the user who views the page rather than their own user. This happens when we need to sanitize things. Okay, so yeah, you're probably already familiar with sanitizing HTML. There's a helper in Rails that looks like that, and it essentially just takes out things that are not allowed. Other things that we need to sanitize, CSS. It's possible to execute malicious code via CSS. URLs. We have to sanitize our URLs. If someone's giving us a URL, we have to make sure that it's okay to put on the page. It's something that is easy to forget. If we wanted people to do custom SQL queries like where clauses, I would not recommend that, but if we needed to, we would have to sanitize it. A sort of suggestion about sanitizing is don't roll your own. Why? Because this is not a year. This is the number of lines in Rails HTML sanitization code. If you're trying to sanitize HTML, which I would not recommend, doesn't have this many lines, is it because you're more clever than them? It could be. It's probably because you forgot something. It's very effective when it's when it's possible to do, very effective. But don't do it yourself. Yeah, some people can do this, but most people I just say don't try it. Yeah, so our next method of handling data is kind of what you call safe data handling. So this is when you need to treat, instead of treating user input as code, you're treating it as data. So if somebody gives you this, types this into their text area, you don't want to like evaluate this, or like you weren't expecting it to know. You just want to show what they wrote. So that so we transform that to that, right? So that's using the H helper or the escape HTML helper. That's safe data handling. We should be pretty familiar with this. Another example is we take our favorite musical group and we need to put it in a SQL query. That's safe data handling. Another word is escaping. That's a word that we use a lot. Or we take our favorite musical group and we need to send it in a URL as a parameter. It looks like that. Right, so when you put it in a URL, Rails usually does this for you. But this is another example of safe data handling. The ampersand got transformed to this %26 business. This is super effective, but it only works if we're treating the data that they gave us as data and not code, which we can't always do. So if you need to roll your own, at least do it with the grammar in front of you. So like if the RFC has grammar, have that in front of you so you can know all the edge cases. So finally, our last way of handling bad user input, last category, I'd say, looks like this. There's semantic checks. So there's nothing really about the data, it's just more about the semantics of your application. And this, the first example is we only want a user to transfer money from an account if they own the account, right? Or if the balance is greater than 0, because if they transferred more than that, would that be the company's money? Like how we'd have to work all that out. So these are called semantic checks. These are also extremely important, and a lot of your code is probably going to look like this. Okay, so yeah, these are the ways. Like some ways of handling data falls into multiple of these categories. These overlap. For example, HTML's sanitizer uses a whitelist and is sort of considered sanitization. But these are, if you have this foundation, it's a pretty good foundation for how you can treat most data in a way that can protect you if you choose the right way to treat it. So you need to know your options here. So I'm hoping that this gives you a good foundation for that. I don't, there's way too much to talk about in one talk or one series of talks or one lecture series of talks. So my biggest recommendation is to learn on your own. The very first thing to do, if you have not read this, is read the Rails security guide. Every Rails developer who's not read this should go read this now. It's really good. It talks about a lot of things that you probably hadn't thought of, and it tells you how Rails handles that or how you need to deal with that. That's a great start, but that's not all. There are many, many edge cases. Our apps are large, and they have lots of components, and they have lots of surface area. So we have to really just start to learn more and more and to know more and more. So get on Google. There's plenty of great resources out there. Another recommendation I'd like to make for you guys, if you want to make security, if you want to make your app secure, is you need to have code review. Code review looks like this. So a manual code review is for security would be when you trace user control of the data through the app. So it comes in through the controller usually, so it's a parameter. You do something with this, maybe put it on the page. Maybe you put it in the database, and then somewhere else you're getting it out of the database. So you need to trace the path of all that data and figure out, you have to determine every place that you use the data, whether you're handling it correctly. Another part of a code review is looking for signatures for common vulnerabilities. This is otherwise known as having an experienced Rails developer look over your code, because they are used to looking for all these different things in their own. There are some tools that do this for you. I'm going to show you one on the next slide that can do some of this for you. And then the third part of the code review is you want to review the risky code. So if you're transferring money, the code that actually like sets off a transfer or a transaction, you need to review that, because that's probably like those are the hotspots. You can find the hotspots for attackers. So Brakeman is a great tool that uses static analysis, so it just looks at your source code, and it looks for certain patterns for certain patterns in ways that we break security. If you have CI, put this on CI to have it run every check-in or something like that. And just even if it doesn't break, even if it doesn't cause CI to stop, you can at least have it send you email your report, right? There's other tools like Code Climate will do some of this kind of stuff for you. Next recommendation, lean on the community. We have a fantastic community. We have a lot of these things that I like to call gems. The Ruby Toolbox has a great list of them. It categorizes them. So there's a security section. There's a section about authentication and authorization and stuff like that. It also ranks them according to how many GitHub stars they have, follows, or forks, that sort of thing. I don't always recommend star-driven development, but I think that's a good place to start with it. Yeah, so get familiar with what's available. Don't roll your own stuff. Look for things that other people have done. Yeah, don't roll your own sanitization, scaping, encoding, safe data handling stuff. Authentication, you don't have to roll your own authentication. We have great libraries for this. If you are rolling your own, you better be a security expert, because a lot of the stuff, if you look through the source code for Devise, for instance, I see stuff that I would never have thought that we needed to do. Don't roll your own cryptography. You need to use you have to know what the right use cases for SHAs, like SHA-1, digest are, HMAX, that sort of thing. They have their own, they can't, your test might pass, they might satisfy the requirements, but it might not satisfy the security requirements. It might leak data in ways that you don't expect if you don't understand how that works. So it's important stuff to know. This is Devise. Devise is probably the leading authorization or authentication gem. It's a gem that you just throw up in Rails and makes it pretty easy to get up and started really quickly. I don't always love it. I find myself fighting with it sometimes, but what I do love is that they've done all the security work for me, and I don't find myself fighting with that. I do have not rolling your own cryptography, I do have an exception. If your name is Bruce Schneier, you are allowed to roll your own cryptography stuff. If you're unfamiliar with this guy, he's been in the news for this. He's a journalist, and breaks some of the Snowden stuff. He's sort of the Chuck Norris of security. He can factor prime numbers on his head, or there'd be prime factorization on his head, but he can factor prime numbers on the head. Yeah. Next recommendation, use Rails. So, Sinatra is nice, it has its use cases, and I love Sinatra, and I use it frequently. But when you're when your app is on the internet, you need to consider things like session fixation and hijacking, cross-site request forgery, mass assignment, SQL injection, cross-site scripting. These things I'm listing are things that Rails does by default pretty well. And it's not that you can't solve those with Sinatra or with another Ruby framework, but it's that you need to know that you need to solve it. So you have to know that as a problem in the first place, and then you need to know how to solve it. So if security important, just Rails does it pretty well for you already. And if that's a problem for you, optimize Rails rather than Sinatra. Yeah. And that's not my opinion. That's this guy's opinion. So this is UK Katz. He's a member of the Rails core team, the jQuery core team, the Ember.js core team. If you think I'm wrong about the use Rails thing, take it up with him. we need to be keeping Rails up to date. So remember in February, right? We had that vulnerability, and we found that that some applications were not supported, and they didn't have a patch for those for that level of that release of Rails. We need to keep Rails on the. They have a list of releases that they do provide patches for, and you need to keep your Rails app up to date with that, so that you can get those patches. I actually have a friend of mine in Philadelphia that has a small consultancy, and they had 11 apps in production, and this is in February, and a lot of them they did not have patches for them, so they had to take that time then to upgrade to Rails, like 3, or they decided to go to 3 instead of to the high 2s. And that was a really rough month for them. So, be diligent now so you don't have to have that problem later. The Rails security list is amazing. It's really low traffic. I would recommend, if you have an app in production, subscribe to this list. The only thing that comes in on this list is security vulnerabilities and some responses about them sometimes. Yes, do that. It's really easy. There's no reason not to. Next, we need to keep our gems up to date. If one of the problems with upgrading Rails from a really low 2.1 or something to the high 2s or to the 3s, now 4, is that a lot of the gems don't work with the newer versions of Rails. So you need to keep those up to date if you want to be able to upgrade Rails to keep it on the accepted. What's the word for that? The supported list, right? So how do you do that? Bundler already has a command called outdated. You run bundle outdated, and it gives you a list of all your gems from your gem file lock, and it tells you which ones are outdated. Put that in CI, or if you don't have CI, Gymnasium is a service that will do that for you. Yeah, so another reason to keep your bundle up to date, keep your gems up to date, is that sometimes oftentimes your gems will have security vulnerabilities in them. There's a tool called Bundler Audit. It's a gem. So if you have your laptop open, get that right now and run it on your app. And what it does is it compares the gem file lock, so the versions of your gems, with those that are in the open source vulnerabilities database. And it will tell you which gems have known vulnerabilities in them. So there's absolutely no reason not to do that. Next, it's important to keep our code clean. If it's not clean, then there's likely to be, we're hiding security vulnerabilities in the mess, right? So learn good object-oriented design. There's a lot of great resources, a lot of great books. Sandy Met's book, our keynote this morning, her book, Practical Object-Oriented Design with Ruby, is amazing, and it's really accessible. There's code metrics tools that will tell you when you're not being dry and when you have too much complexity in your methods. Use those. Pair programming is a great way. Yes, that is me. And yes, I am wearing the same shirt in that picture. I did not take that at this moment. Pair programming is a great way to get more eyes on your code, and it actually does make your code cleaner when you have somebody else there and you're both agreeing on what you're going to be committing. That goes really well with TDD. TDD, if you do the refactoring step, will help you have cleaner code. And once you're testing, you write regression tests for your vulnerabilities. So when you find a vulnerability, like maybe a developer comes and says, hey, we didn't, we're just displaying, we're just linking to URLs that have been given to us without sanitizing them, which is actually pretty common. When the developer comes up with that, write a regression test that tests, that fails when the vulnerability exists. So then you fix it, and then you test it passed. And so as soon as that test fails again, maybe somebody changed something, you'll know that you're vulnerable again. You can't do that if you don't have automated tests. So please have automated tests. Then my last recommendation is an outside security audit. So what do I mean by outside? So maybe some experienced Rails developers that have consultancies in Philadelphia. Shameless self-promotion. But maybe it's outside your company, or maybe it's outside your team. So if you have experienced developers in your company that aren't your team, they have fresh eyes. They don't have the same assumptions that you do. Get them to look at your code. And that can be really valuable. So to wrap up, security is really hard. I hope I've stimulated into taking some action to start learning. I really don't, wasn't really trying to get too much information in your head because there's not enough time, and I'm not smart enough to do that. It's really hard, but we have a great community. We have great resources, and a lot of work has been done for us already. So I want to give you a little bit, just close with a little bit more perspective. Like those in the security community, which I'm not, I don't consider myself that at all. There's this idea that like we'll make our app so secure that nobody will ever be able to get to our data. Right, but there are many ways of getting to your data, and it's not always through the app. So there's some perspective there. There's legal ways. So do your due diligence and learn what you need to know, and you can make your app as secure as it needs to be. So thanks.